Good morning, students. Welcome to class on, sorry about that. That is completely the wrong stuff. There we go. All right. Good morning, class. Hope you guys are having a good early morning so far on Thursday. I am sitting here with my cool headphones on, ready to make a video for you guys and teach you a little geometry. Let's start off. My wife is whispering something. What's that, Linda? It's Thankful Thursday. I've never heard of that. Wow. So my wife has now contributed to your education, even though probably most of you have never met her. Thankful Thursday. Well, because we're thankful, we're going to be thankful that we have a quiz tomorrow. So please don't forget we have a quiz tomorrow. We'll go over that in just a second. You also owe me homework. Now, those that completed the entire assignment last night get a good job from me, so good job, and you also get 2 bonus points in your account, so please make note of that. And then also we're doing something we started about 3 or 4 weeks ago. Anything not turned in this week, you will not make up unless you're absent. Okay, I'm sorry. I am really putting the clamps down on that, so when I pick up my notebook on Sunday from Berean, anything not turned in will be zeros unless you email me or call me. Just don't text, because I do not text. So turn your homework in now at this time. Even if you didn't finish it, you turn it in. You get 100. If you did 10 problems, you get 100. If you did them all, you get 100. So please turn it in. Let me go ahead and go over the quiz quickly. So as you're turning your homework in, get your notebooks out or whatever you're going to take notes in for what's going to be on the quiz tomorrow. Let me show you what's going to be on the quiz. I gave you a couple bonus point opportunities on Tuesday, some last night. I'll give you a couple more today. And the video Tuesday was 53 minutes. The one yesterday was 53 minutes. So I am going to try to be a little short-winded today and go a little faster and keep this hopefully a little shorter. All right. So if you brought your pillows, put those away, because I'm going to try to be a little shorter today. Okay, you're going to have to know these 3 definitions on your quiz tomorrow. Now, you can write the definition down if you want. You've got it in your notes somewhere. Just make note of the fact that I'm going to ask you to fill in the blank for what a solid is. I'm going to ask you to fill in the blank for what a polyhedron is. And I'm going to ask you to fill in the blank for what a prism is. Okay? So know those 3 definitions. Remember my philosophy, I go fast. You can always pause the video, but you can't speed me up. So I'm going to move on. These 3 definitions will be on your quiz tomorrow. I would be real familiar with this chart, so you might want to make notes somewhere in your notes. Page 475 at the bottom, this chart right here. I mean, you should be able to look at an object and tell me if it's a rectangular prism, if it's a triangular prism, if it's a cube, if it's a pyramid. If it is a pyramid, is it a rectangular pyramid? Is it a triangular pyramid? Is it a pentagonal pyramid, hexagonal, heptagonal? All of those are fair game questions, okay? And of course, how you know is you look at the base. If the base is a rectangle, then it's a rectangular pyramid. If the base is a pyramid or a triangle, then it's a triangular pyramid. And then of course, down here, you should recognize a cylinder, you should recognize a cone, you should recognize a sphere, okay? So be familiar with all of those. And then if you want a little review, the homework, remember BAG stands for Berean Academy Geometry. So BAG 9-1 homework. There's a video you can look up if you want to. And you should be responsible for those problems. Now, most of these problems here that could be on your quiz, they're pretty much just saying, is it a polyhedron? Is it not a polyhedron? Is it a prism? Is it not? What type of prism? Etc., etc. So let's go back to this page here. Remember, a cylinder, a cone, a sphere, none of these are polyhedrons because they have curved polygons for some of their faces. All of these here would be all of these would be polyhedrons right here, all of these, okay? Because all of their faces are polygons. Every single one of their faces is a polygon. So, look this homework over here. That's pretty simple, though. It's pretty much just defining things. Now, do you remember some of this? Now, I'm not asking you to write this whole problem down, but remember how we found the surface area of rectangular prisms? Remember this problem we did? Well, I'm going to have you find some surface areas. So be familiar with the rectangular prism. There's a top, a bottom, a right, left, a front, and a back. Be familiar with finding the surface area of a triangular prism. Again, if I'm going too fast, you just push the pause button. No big deal, students, okay? And you're not supposed to write all these numbers down. I'm just giving you examples. A triangular prism, you should be able to find the surface area of that. Okay? How about a cylinder? You should be able to find the surface area of a cylinder. Okay? All of those are fair game, but you know what? You know what else is fair game, students, ladies? Is lateral surface area. So remember, the lateral surface area would be like, for example, this object right here, this solid. It would be the surface area of all the sides except the top and the bottom. Your two bases, you would subtract those out. That's what lateral surface area is. So on a cylinder, we have a formula. This whole thing, let me get a different color of pen here. This whole formula here is for the surface area of a whole cylinder, and this little part here is how you find the lateral surface area. So please be familiar with that. If you want some practice problems because you just love math so much, this would be a good place to start. Bag 9-2 homework. Bag 9-2 homework. And if you look that video up, you'll see this is the assignment right here, and there's some good practice problems there you've done already. And you probably have your homework you could look at. And maybe we should try to start this down. Maybe we should stop turning homework in, since I don't collect it and grade it and pass it back the next day like I used to. Maybe we should start next week where you guys don't, well, I don't know, because then for some of you would put off your homework to the end of the week. So let's forget that idea. But anyways, there's an assignment there that will help you get ready for your quiz. Now here's something brand new that you're not going to like. In the past, I never put on your quiz the stuff that we did the day before a quiz, and the reason for that was you couldn't ask questions on your homework until the next day. Well, that's no longer an issue because you have the wonderful Mr. Earhart videos to watch every night to help you with your homework. So what I teach you today in class is also going to be in the quiz tomorrow. Now, I know that's not exactly, making you happy, and it's something that's new, but it's fair. It's totally fair because you're supposed to take notes, you're supposed to listen, you're supposed to do your homework tonight. And if you don't understand your homework, you're supposed to watch the video that I make every day for you. So anything from today's class and anything from today's homework I'm going to give you is also going to be on the quiz tomorrow. Okay? So I'm moving on. If I went too fast, pause the video, back it up, go over all that again. I'm going to go ahead and move on. Okay? So grab your notebooks. And I think I'll be done teaching this in probably about 15 or 20 minutes, 25 at the most, probably about 20 minutes. Not a very long lesson. We're doing half of a lesson today of 9.3 and the other half tomorrow. Okay? So, students, here we go. Your heading today is surface area of pyramids. Surface area of pyramids. So far we've learned how to find the surface area of prisms. We've also learned how to find the surface area of cylinders. And now today, we are going to learn how to find the surface area of pyramids, okay? The surface area of pyramids, lesson 9.3, and today is the 4th. All right, as you're copying this down, I would like to encourage you to go ahead and turn to page 491 in your books. That's page 491, page 491. I want you to look at something. I really need to drill into your heads the difference between the height of a pyramid and the slant height. Okay, so hopefully you've copied this down. We're going to move on. If you'll turn to page 490, I'm not sure why I have 497 right here. That's incorrect. It is 491. So let me fix that. If you'll look at the top of page 491, you're going to see these exact same two pictures that are on the screen here in front of you. They're also at the top of page 491. Okay, so let's talk about, look at my pen here, please, students. Let's talk about the height of a pyramid and the slant height. Now, let's talk about the height. Here's what the height of a pyramid is. Are you ready? Let's pretend that you climbed up this pyramid. So watch my marker. Here I go. This is you climbing to the top of the pyramid, okay? And let's pretend there's a hole right there. And you took a weighted metal chain, and I say weighted so it'll go straight down and not kind of, blow around with the wind or whatever. So you drop this weighted chain straight down this hole so it lands inside the pyramid right on the ground. Well, if you did that, that is the height of the pyramid, okay? So the height of the pyramid is the inside from the top, like there was a hole straight down. Or let's pretend you wanted to climb down the rope to get to the inside and you drop the rope down. That rope would be the height of the pyramid, okay? Now let's take a look at what slant height is over here. Slant height. Slant height would be like you climbed to the top of the pyramid and then you had a friend at the bottom. Now I'm going to show off my drawing skills. Here's your friend right here. There we go. A stick figure. and you're gonna toss a rope down the side of the pyramid to them so they can scale up the side of the pyramid. And so here you toss the rope down the outside, and it just lays on the wall here. It lays on the wall, and your friend grabs it, and up they go. All right, that would be the slant height. Do you see the difference? You really need to before we go any further. The straight up and down height, the straight up and down measurement is the height, and the height of the side of a wall like this would be the slant height. You do need to know the difference between those two. Okay? Now, I'd like you to go ahead and stay on that page, and I'd like you to make a note in your notes somewhere that we are going to look at page 491, example number 1. So go ahead and write right here in your notes. I would write in your notes page 491, example number 1. The reason I would write that is because I don't want you to have to draw this figure in your notes. It's not easy to do. So go ahead and write in your notes page 491, example number 1. Okay, this example says, find the slant height of this pyramid, of the rainforest pyramid. Find the slant height. Now, the reason they want you to find the slant height is later on, please listen to me, we're going to start finding the surface area of the pyramids. And one of the things you have to find the surface area of the pyramid is the slant height. So if you don't know the slant height, you have to know how to find it. So right now I'm going to teach you how to find the slant height. Please watch carefully. Are you ready? Watch my pen. Okay, here's the height that's straight down to the inside of the triangle. Everybody see that? Now let's say that you were inside the triangle and you walked straight over and you put a line like this, and that line hit right there. And then look at this line here, the slant height coming down. Do you not see what we have here? We have a right triangle. Do you see that? Now, the height going straight up and down, they gave you the height. I'm going to go over that one more time very quickly in case some of you didn't see that. Look at this height going straight down like the rope that you dropped straight down the middle of the pyramid. Then you slid down the rope, and now you're inside the pyramid. And then you walked over with another rope, and you took a rope and you put it right there. And then on the outside of the pyramid is this slant coming down. This line here is the slant height. You have a right triangle right there. And guess what? Do you see this right triangle? I'm going to draw it right here. You know this side here is 100. How do you know that, Mr. Earhart? Well, this height right here, going up and down, that's 100. Look at that. You know what this is. I do? Well, sure you do. Look, aren't you right in the middle of the pyramid here? And you walk straight over to here. What is the whole length of the pyramid going all the way across? Isn't it 200? So what's half of that? 100? So if you're in the middle of this pyramid and you walk over to here, this length, now watch my marker here. This length right here, that black line, is the same as this right here. It's a half of this side right here. So it's also going to be 100. Now, I'm not saying the height here will always be the same as this length. That's a coincidence, okay? But my point is whatever this length is right here going across, this length here is going to be half of that. So this is 100 also. So now, using Pythagorean's theorem, we can find the hypotenuse. Remember how to find the hypotenuse? So we got L squared plus L squared equals H squared. So one leg is 100, and the other leg is 100, and the hypotenuse is 8 squared. With your calculators, if you square 100 and square 100 and add them together, you will get 20,000. You can trust me or type that in your calculator, whatever you want to do. So 20,000 equals 8 squared. So we take the square root of both sides, and look in your book there, you'll see the answer. It's 141.42. When you take the square root of one side, you take the square root of the other side. Oh, Mr. Earhart, you forgot to put the plus minus. Well, when we're dealing with a length, there is no such thing as the negative length. So I'm not really worried about the plus negative, or the plus minus, or the positive negative. So there's your slant height. So you learned how to find the slant height. So the slant height, this red line right here that my pen is on right now, that slant height is 141.42. Okay? So with that, or they rounded to 141. So with that in mind, let's look at it again, because I'm going to turn you loose and give you a bonus point in a second. Let you do one of these on your own. So come back up here real quick. I want you to find the slant height, okay? So remember, the line that goes, let me get a different color here. The line that goes straight down is your height. Then you draw a line straight over to your slant height, and you have a right triangle right there. And there's your right triangle. And now we know the height is 100. That was given to us. What is this whole length here? 200. So this length here is half of that. So we know this is 100. And then use Pythagorean's theorem for this missing side for the hypotenuse. Now, I'll tell you what, for your notes, I don't want you to waste time trying to draw this picture. I'm going to make it a little bigger for you guys in case you can't see it. Go ahead and find the slant height. I'm going to go ahead and draw the slant height for you so you get a picture of it. This is the height going straight up and down. The height going straight up and down is 85. Okay, hopefully y'all can see that. Okay, so there's the height going straight up and down right there. I want you to find the slant height, and here it is. It's coming down the side of this wall right here, and I want you to find the slant height. So do not pause the video. I'm just going to sit here and be quiet. Just let it run. I'm going to give you about a minute to go ahead and draw your right triangle, and then over here I would draw the right triangle to help you see it, and use Pythagorean's theorem and find the slant height. Okay, hopefully you're working diligently. Keep working there. Use your notes. This is for a bonus point, so don't use a friend unless you're going to forfeit your bonus points. And go ahead and find the surface area. Excuse me, sorry. Go ahead and find the slant height. The slant height. Okay, I am going to start working on the problem now, and I'm going to start talking about it. So if there are people still working, just go ahead and pause the video, please, at this time. So someone stand up there and quickly pause the video. I'm going to keep going like it's not being paused. Okay, I've asked you to find the slant height of this line right here that my pen is on going down. And so I'm going to draw my right triangle like this, draw this line coming over here, put a right angle right here. And I'm going to go ahead and draw my triangle off to the side so I can see it a little better. Okay, well this length right here should be 85. You should be able to see that, okay? And this length, well, we know this whole length here is 40, and so this length here is half of that, so this length right here should be 20. I hope you use 20. So we have leg squared plus leg squared equals hypotenuse squared. And I'll be honest with you, I'm not totally prepared, so I'm going to very quickly type in 85 squared plus 20 squared, and I'm getting 7,625. Hopefully that's what you're getting. Hopefully I've not made a mistake. And now we're going to take the square root of both sides. And I'm getting 87.3212. I'm going to round to the nearest whole number. So I'm going to say the slant height is 87 centimeters. 87 centimeters. Okay, I hope you did well on that. Now we're going to do 4 problems to give you closure. And now you can see why I've cut this less than half. I'm trying to go really slow and be helpful and not give you too much information to digest, because we're going to now go ahead and find the surface area of 4 pyramids. I'll go quickly, take some really good notes. And you have to know the slant height in order to do that. So that's why we learned that. Okay. All right, here is the formula. In order to find the surface area of a pyramid, so write this down. We are now going to start. Oh, by the way, that last problem was for a bonus point, but so be sure and give that to you. Give that to yourself if you got that right. Okay, write this in your notes, please. Surface area of a pyramid. Surface area of a pyramid. And here's the formula. Here it is. It's S for surface area equals capital B plus 1/2 capital P, and then the cursive letter L. Okay? Let me go ahead and give you some descriptions here on what each of these stand for. Okay? B is the area of the base. Okay? So you're going to have to find the area of the base. For example, let's look at that last problem that we just had in our notes. What was your base, class? I'm going to highlight it. You see that base? Someone call it out. Good job, Ashley. Well done. There's the base. All right, so there's my base. So I would find the area of a square. Area of a square. All right, so you find the area of the base. Now P actually stands for, capital P stands for the, write all this down please, it stands for the perimeter of the base. So the perimeter of the base. So let's go back and look at that last problem we just had. If I asked you to find the perimeter of that base, well, you would have 40, 40, 40, and 40, so that would be 160. You would add up all four sides for the perimeter. This isn't that hard. And then guess what L stands for? Remember why I told you we had to learn how to find the slant height? The slant height? Well, if you don't know it, you've got to find it. L stands for the slant height. So to find the surface area of a pyramid, we're going to do 4 of these problems very quickly. You have to find the area of the base, the perimeter of the base, and the slant height. And once you've done those things, you will be good. Okay? So let me see if I can cut and paste this so I won't have to continue to copy that over and over. And here we go. All right, I would like you to write in your notes. Let's do 4 of these problems. Are you ready, students? Please turn your notes to page 492 and write down example number 2. Please write in your notes, page 492, example number 2. And we are going to find the surface area of this pyramid, the surface area of this pyramid. Well, we need to find 3 things. Again, I would not try to draw this object. Just look in your book, page 492, example number 2. You know we're going to have to find the area of the base. You know we're going to have to find the perimeter of the base, and you know we're going to have to find the slant height. Well, 2 of these are really easy. Please look at the base. I'm going to highlight the base for you. Do you see the base right there? There's your base. Well, that's a square. Okay, that's a square. How do you find the area of a square? Well, length times width, 6 times 6. So the area of the base is 36. That's pretty easy. Now, P stands for the perimeter of the base. Let's find the perimeter. 6 plus 6 plus 6 plus 6. So the perimeter is 24. If I'm going too fast, pause it, talk to some friends, get some help, or back it up. But that's how you would find the perimeter and the area of the base. Now the slant height. This is where it gets a little tricky. Let's go ahead and draw our triangle. Here's the slant height. We come down. That's the height, and then over. And I've got to find this slant height right here. So a little right angle. So here's my triangle right here. And this side here has a length of 4. If this whole side here is 6, then I know this side here has a length of 3. And now using Pythagorean's theorem, I would have 4 squared plus 3 squared equals 8 squared. And that would be 25 equals 8 squared. And take the square root of both sides, 5 equals 8. So there's your slant height. So you found the slant height, okay? And now we're ready for our formula, all right? And I'm going to try to paste this. Yeah, I can do that. There we go. So there we go. And let's see if we can't change that color. There we go. So here's the formula. I've got to say something to my son real quick here. Just hold on one second. Okay, 1 second. So here is the formula we're going to use for the surface area of a pyramid. So for B, I'm going to put 36. For 1/2, I'm going to put 1/2. For P, I'm going to put 24. And for the slant height, I'm going to put 5. Now, of course, we know we do our multiplication first. So I'm going to bring the 36 down. And then we have 1/2 times 24 times 5. That would give you 60. Okay? That would give you 60. And then if you add those 2 together, you will get 96. Now it's surface area, so it's square feet. So 96 square feet. All right, so there's 1, 3 more to go, and we're finished for the class period. The next problem I would like you to write in your notes is page 493, at the top, number 1. Now I'm going to go quickly, so here we go. Page 493, at the top, number 1. Are you ready? We're going to find the surface area of this pyramid. Surface area of this pyramid. So, here's my formula right here. Let's pull this down here. And so if that is the formula, then I know I've got to find the area of the base equals blank I've got to find the perimeter of the base equals blank, and I've got to find the slant height. Well, look, we can find the area of the base so quickly. I have a square. Do y'all see the square right here? 7 times 7 is 49. So there's the area of the base. How about the perimeter? 7 plus 7 plus 7 plus 7, all four sides, so the perimeter would be 28. And now let's see if we can't find the slant height real quick. All right. So the slant height, of course, is this blue line here. I'm going to go ahead and, oh, in this case, they've given the slant height. I didn't notice that. So do you see that there? They have given us the slant height. So they've taken it kind of easy on us. That's nice of them. Look at that. The slant height right there is 9, so we don't have to find it. Rest assured, I will not give you one like this on the quiz. That's too easy. But anyways, the slant height is 9. Okay? So with that in mind, I'm going to grab this thing and pull it over here, and let's make some substitutions. All right, where the B is, I'm going to put 49. Where the 1/2 is, I'm going to put 1/2. Where the P is, I'm going to put 9. That's not correct. Sorry about that. Where the P is, I'm going to put 28. And where the L is, I'm going to put a 9. All right, well, you do your multiplication first. So we have 49 plus, let's see, I think 126. I did that in my head. I hope that's correct. And then if you add these two numbers together, you do get 175 square inches. There we go. 2 more to go, and we're done. All right, let's go a little faster here. Let's try the next one. In your notes, I'd like you to write down page 493, number 2. Page 493, number 2. This one's even easier than the last one, so you guys are kind of lucking out on this. All right, page 493, number 2 at the top. All right, we're going to find the surface area of this pyramid. So we know we're going to have to find the area of the base. We know we're going to have to find the perimeter of the base. And we know we're going to have to find the slant height. Those 3 things. Look, do you see this capital B right here? We don't have to find the area of the base. They just gave it to us. All right, so the area of the base is 35.1. That was easy enough. No work there. Now we got to find the perimeter of the base. Well, if you'll notice, we have a, now watch this, look in your books, we have a length of 9 right here. Do you see that? A length of 9. And see that red tick mark right there in your book? Well, look at this red tick mark over here and this red mark. That means all of those 3 triangular base sides are congruent. So that means if this is 9, then this is also a 9, and this is also a 9. So all 3 sides of the base of your triangle are 9. So the perimeter is going to be 27. 9, 9, and 9. And then the slant height, look, they gave it to you again. It's right here. They gave it to you. So that's pretty easy. Your slant height would be 12. So using those numbers, let's find the perimeter of the pyramid, or the surface area of the pyramid. Okay, for B, I'm going to put 35.1. For 1/2, I'm going to put 1/2. For P, I'm going to put 27. And for my slant height, I'm going to put 12. And I'm trying to do this in my head, so be patient, please, if I make a mistake. It would be what, 42? I'm getting, I think it's 162, I believe. And that would be 35, 7, 197. Yes, that's correct. So 162. And then if you add these two together, you will get 197.1. So 197.1 centimeters squared, because it is surface area. All right? All right, let's move on, students, to the last problem, and we're done. So congratulations. This will be a little more challenging for you here, which is good. We need that. So, all right, let's find the surface area of this pyramid. The surface area of this pyramid. If we're going to find the surface area of a pyramid, we know that we need to find the area of the base. We need to find the perimeter of the base, and we need to find the slant height. So here we go. The area of the base should be pretty simple. We have a square right here. It's a 10 by 10 square, so the area would be 100. Okay? The perimeter should be 40. 10 plus 10 plus 10 plus 10. So the perimeter should be 40. And now let's see if we can't find the slant height real quick. Okay? Well, here is my slant height. They didn't draw it for you, but it's this line right here. I'm going to go really slow and try to draw it well. So there's my slant height. And here's the regular height coming straight down. And then we're going to go straight over. And there's my right triangle. So I'm going to go ahead and put my right triangle. I'm kind of running out of room here. Hopefully you already made note that we're on page 493 at the top. Number 3, I'm going to use that space here. So here's my triangle right here. And this side right here would be 12. That's the height. This side right here would be 5. Remember, it's always half of this whole side right here. This length here is always half like this. So we have a 5. And of course, we're looking for this side here. So we have 12 squared plus 5 squared equals hypotenuse squared. And that should be, let's see, 144 plus 25, 144, 25, 169. 169 equals 8 squared. And that's actually a perfect square. If you take the square root of both sides, you'll get 13 exactly, because 13 times 13 is 169. So your slant height is going to be 13 right here. So now we know the slant height. So now that we know all 3 values that we needed to know, we can substitute them in. For B, I'll put a 100. For 1/2, I will just leave that 1/2. For P, I'm going to substitute 40. And for L, I'm going to substitute 13. Bring the 100 down and do your multiplication first. Let's see, 20 times 13 would be 260. And then if you multiply all these, 260, add those two together, and your answer will be 360 feet squared. I've tried to make this a little shorter. I hope that I've been able to do that. That is how you find the surface area of a pyramid. Now you see why I've divided this into 2 days. I knew first of all we had to tackle how to find the slant height, and then of course once you know how to do that, finding the surface area of the pyramid is pretty simple. Here's your homework for tonight. It's pretty reasonable. It's just 9 problems, so not too bad. Also study for your quiz tonight, okay? Of course, you know by now the video will be Berean Academy Geometry, so bag, and then 9-3, and then homework. So if you want to make note of that, that is the video you will want to watch if you need help. I will not be in class tomorrow. Mr. Harmon will give the quiz, so please make sure you're ready for this quiz. All right, have a great rest of the day.